Okay, in this video we're going to graph some piecewise functions and then we're going to talk about whether or not they're continuous or not. Okay, so how we're going to go about that is we're going to break this into pieces. We're going to look at the top part first and notice that the boundary line between these two pieces of this is x equals 1. Okay, and notice that they're both linear functions. So what I'm going to do is look at that boundary line, which is x equals 1, and I'm going to plug x equals 1 into both of those to see where they're at. Okay, let's start with the top one. So we have 2x minus 1. So if I have f of x is equal to, or f of 1, excuse me, and I'm plugging it into 2x minus 1, that'll be 2 times 1 minus 1. Okay, so 2 times 1 minus 1 is equal to 1. Okay, so that gives me the point on this top graph of 1 comma 1. Okay, so I can go to the graph and I can find the point 1 comma 1, plugged in a 1 and got a 1 out, right? And since there's no line underneath, no equal to sign here on this top one, I'm going to put an open dot right there. Okay, and now that we have that, we can look at what the rest of the graph is doing. So we need to look at the slope of that. And the slope is the number in front of x. So m is equal to 2, which is the same thing as 2 over 1. We could also write that as negative 2 over negative 1. Keep in mind those two are the exact same things. Okay, and the reason we want to use this second one is because this says if x is less than 1. Okay, if we use this rise over run, starting from this point, we'd be going up 2 and right 1, up 2, right 1. And that's not less than 1. So we need to use the other one so that it goes the other direction. So we use this negative 2 over negative 1. Remember, rise over run. So I would go down 2, 1, 2, left 1. Down 2, left 1. Okay, so the graph would look like this. Okay, so that's the left part. That is the 2x minus 1 if x is less than 1. Okay, now I'm going to look at the other part. Okay, so I have a negative x plus 2. So for that one, I'm going to say, I'm also going to plug in the f of 1 right here. And I'm going to say that that is negative parentheses 1 plus 2. Okay, so that will give me negative 1 plus 2, which is 1. So that also gives me the point 1 comma 1. At this time, we're going to have an equal to sign. So I'll go to this same point, 1 comma 1, and I'll put a solid dot there. So that's going to cover up that open dot. Okay. And now I can use the slope. Notice the slope is the number in front of x. So m is equal to negative 1 over 1, or it could be written as 1 over negative 1. Both of those are the same. Okay. And this says x has to be greater than 1. So I need to go over here to the right. Okay, so which one do I use? Do I use the one that goes down 1 to the right 1, or do I use the one that goes up 1 to the left 1? Well, I'm going to use this one because I need to be to the right. Okay, so I'll go down 1, right 1, down 1, right 1. Okay, so down 1, right 1, here's a point, there's a point. Okay, and get enough of them to create your graph. Okay, so it's going to look basically like that. Okay, so that's the graph of the piecewise function. Now I need to ask myself, is it continuous or not? Okay, and the thing about continuity is that if you can graph this graph without raising up your pencil or your pen, then it's continuous. If you ever have to pick up your pencil or your pen, even to write an open dot, then it's not continuous. So can I graph this without lifting my pencil? Yes, I can. So there's no gaps in this, there's no holes in this. This is something that I can just write with one without ever picking up my pencil. So this is a continuous function. Okay, let's do another one. So in this one we have 5x minus 4 for the top function. And the bottom one we have negative x plus 4. Okay, so again we have this boundary of 1. Okay, so what I'm going to do is I'm going to plug a 1 into 5x minus 4. So 5 times 1 minus 4. 5 minus 4 is equal to 1. Okay, so when I plugged in a 1, I got a 1 out. So that's the point 1, 1. Okay, and this has a equal to sign underneath right here. So when I go to the point 1, 1, I'm going to put a closed circle. 1, 1, closed circle, closed dot. Okay, And And now it says it's less than or equal to 1. Less than or equal to 1 means left. So when I write my slope, m is equal to 5 over 1. I could also write it as negative 5 over negative 1. I need to go left. Okay, so this bottom number tells me that I'm going to go left on this one, right, because it's negative 1. So rise over run, I would go down 5, left 1, down 5, left 1. And I want to be left, okay, because it says less than 1. So that's the one I'm going to use. So 1, 2, 3, 4, 5, 1. And notice that that's also your y-intercept right here. Okay, so we can use that, and we could do one more if you wanted to, but that's good enough. All right, now let's look at the other one, x minus 4. So if I plug a 1 in, I get negative 1 plus 4 is equal to 3. So when I plug in a 1, I get a 3. Okay, so that corresponds to the point 1, comma 3. And if I look at this, there's no line underneath, so that's an open dot. So 1, comma 3 with an open dot. And now I look at my slope. M is equal to negative 1 over 1 or 1 over negative 1. I want to be greater than 1, which means I want to go to the right. So I'm using this one. This one is going to be down 1, right 1, down 1, right 1. So this is the slope I want to use. Okay, so I go down 1, right 1, like this. That's good enough. Okay, so there's my graph. Okay, now the question is this continuous or not? Okay, so back to what we said. Can you write this without lifting up your pen or pencil? And the answer is no, you can't, because if you draw it right here, you'll have to stop, lift up your pencil or pen, put it back down, draw your open dot, and then keep going. Okay, so this has a gap in it. Okay, so this is no. The function is not continuous. Okay, let's do another one. So this one we have f of x equals negative 5x plus 3 when x is less than or equal to 2, and it's equal to x minus 4 if x is greater than 2. Okay, so our boundary line is 2. That's the number we're going to plug in. Okay, so look at the top one first. So if I plug in a 2, negative 5 times 2 plus 3, plugging in a 2, that is negative 10 plus 3, which is negative 7. So that's the point, 2, negative 7. Okay, there is a line underneath here. That means it's equal to. So when I go to this point, I'm going to put a solid dot. So 1, 2 over, and 7 down, and that is here, a solid dot. Okay. My slope is equal to negative 5 over 1, the number in front of x, put it over 1, or 5 positive over negative 1. Okay. Looking at this, it says I need to be less than 2, which is left of 2. I need to be over here. So I need to use this one because it has a negative number on the bottom that's going left. So 5 up, left 1. 5 up, left 1. Okay, so I'll go 1, 2, 3, 4, 5. There's a point. And I can also, this should correspond to my y-intercept of 3. So let's try it again. 1, 2, 3, 4, 5. There we go. So it did correspond to the y-intercept. And we can graph that. Okay, so there's one portion of it. Now let's look at the x minus 4 portion of this. Okay, so if we plug in a 2, we get 2 minus 4. Plugging in a 2, I get negative 2 out. That corresponds to the point 2, comma, negative 2. Plug in a 2 for x, get a 2 out, negative 2 out for y. Okay, so this one does not have a line underneath. Okay, so that's an open dot. So I go to the point 2, negative 2 and put an open dot. 2, negative 2 is here, open dot. Okay, and my slope is 1. Okay, so I can put 1 over 1 or negative 1 over negative 1. Now, this says greater than 2, which means I want to be to the right of this point, to the right over here. Okay, so rise over run, one up, 1 right, 1 up, 1 right. So this is the one I want to use because I want to be to the right. Okay, so I go 1 up, 1 over, like this. Okay, so the graph corresponds to this line. Okay, is the graph continuous? Okay, can you draw it without raising your pencil? And the question, or the answer is no, you cannot, because you draw one portion of it, gets here, then you have to lift up, and then draw your open dot, and keep going. Okay, so this one is not continuous, no. Okay, one more. So we have f of x is equal to 3x plus 1 if x is less than negative 2. And it's equal to x minus 3 if x is greater than or equal to negative 2. Okay, so look at the top one first. We're looking at the boundary line, which is negative 2. So I plug in a negative 2. 3 times negative 2 plus 1. That is negative 6 plus 1, which is negative 5. So I plugged in a negative 2 and I got a negative 5 out. So that's negative 2, negative 5. There's no line underneath this, so I'm going to put an open dot. So I go negative 2 on the x and negative 5 on the y. That is an open dot. Okay, and now I use my slope. Slope is the number in front of x, which is 3 over 1, or negative 3 over negative 1. It says less than negative 2. Less than means left. So I need the one that goes left. That's this slope, right? The bottom number is right or left, and since it's negative, it's left. So I'll use negative 3 over negative 1. So 1, 2, 3, negative 1, and that's all I have room for. So there's that portion of the graph. Okay, and now for the other portion at negative 2, we've got x minus 3, so negative 2 minus 3. We plug in a negative 2, we get a negative 5 out. Okay, so that is negative 2, negative 5. That's the exact same point that we just did, but this time it's going to be a closed circle. Okay, so negative 2, negative 5. There's an open circle there, but we're going to fill it up with a closed circle. Okay. Now our slope, m, is equal to the number in front of x, which is a 1. 1 over 1 or negative 1 over negative 1, depending on which one is useful to you. This is greater than negative 2, so I'm going to the right. That's the 1 right here. Up 1, right 1. Up 1, right 1. And I want to be right because this is x greater than negative 2. Okay, so this will go like this. Up 1, right 1. Up 1, right 1, and so on. So it looks basically like this. Okay, that's your graph. Now, is the function continuous? Well, can I draw this without raising my pen? Well, yeah, I can. There we go. I did it. There's no gaps, no breaks, no holes. So, yes, this function is continuous.